So we're going to start off, and we're just going to set up, we're going to start with just sine, okay? And again, we're going to be, everything is in reference to r, although that won't really matter too much because it will work for any angle. All right, but on the previous page, we said sine of r is equal to opposite over hypotenuse, but given the triangle here, it's r over t. Okay, so in the situation that I'm presenting here, the hypothetical is, how can I get r by itself? How can I figure out what the angle is given the side? So suppose that I know r is 12 and t is 17. Can I figure out what r is? And the way we're going to do that is we're going to do the inverse of sine. It's called the inverse of sine, okay? And it's written like this. It looks like it's sine to the negative 1. It's just sine with a little negative 1 there. That means inverse sine. So when you take the inverse sine of both sides, here's what you get. Like all inverses we've talked about in Algebra 2, these undo each other. Okay, so you're left with just r, which is equal to the inverse sine of r over t. All right, you don't even necessarily need to memorize that it's like the inverse sine of opposite over hypotenuse. It's just that if you're trying to find an angle, then you're going to do the inverse of whatever trig ratio you've set up. So I'll give you the rest of them, though, in reference to r. So inverse cosine. So if I give you cosine of r is equal to s over t, then r is equal to the inverse cosine of s over t. And if I give you the tangent of r is equal to r over s, little r over s, then inverse tangent, hold on. What the heck? Sorry, then r is equal to the inverse tangent of r over s. You're going to find that doing the example problems are a lot more helpful for understanding what's going on here. So, any questions on this before we move on to the examples? All right, so let's actually do one. So, here I am trying to figure out what angle t is in all of these, okay? So angle t is here. I'm going to circle that. And then just like the other problems, I'm going to label in reference to t. So 101 is my hypotenuse. Opposite of t is this side over here, which you'd call SR, I guess. But so that's our opposite side. And then the last one here, 32, is the adjacent side. All right, and then I'm going to take and ask myself, what information do I have and what information do I need? I'm looking for this angle t, and I know the hypotenuse, and I know the adjacent side. So which trig ratio relates adjacent and hypotenuse? That's opposite adjacent. Cosine, yeah, it's cosine, right? So I'm going to set this up as cosine of t is equal to adjacent, which is 32, over 101. And again, you're trying to figure out what t is here. So you think, oh shoot, t is inside of cosine. I need a way to undo cosine so that I can get to t. And the way that we undo something is always by its inverse. The inverse of cosine is inverse cosine. And so we're just going to take the inverse cosine of the left, the inverse cosine of the right, and that'll give us our answer. Now, you don't need to write it out every time if you don't want to, because ultimately you're just going to use your calculator. but it might be helpful to have it in your notes. What's that? Right here. Okay, so then in your calculator, you have an inverse button, and I'll show you on Desmos here as well in a second. But if you hit second and then the cosine button, you'll get inverse cosine. You're going to plug in 32 over 101, and you get the angle, 71.5 degrees. Okay. So. Okay, and that's kind of really all there is to it. These problems are just kind of, well, the inverse of what was on the previous page, where you set it up and you're looking for an angle, so you've got to use the inverse of whatever trig function you've set it up as. All right.